Looking at this expression, we have 3 to the power of 2x plus 1, as you can see, minus 26 in bracket 3 to the power of x minus 9 is equal to 0. In fact, looking at this expression, we are looking at the fact that we want to look for the values or unknown value of x or y in this expression. So x is what we see now. So if we look at this expression that is here, we can see that we have 3 into x as a power. We need to must try to express this also to have x as this one. But note that when you see power expression like this, where we have two values like 2x plus 1, then it has been as a result of additions in terms of the power. So in other words, we can still re-express that particular expression here as 3 to the power 2x plus 3 times 3 to the power 1, because this plus that you can see means it has been added in expression in the form of multiple as multiplication. That is, it can still be the same as 3 raised to the power 2x times 3 raised to the power 1. It is as a result of these two that we are able to have this as a power. So it's because of this multiple that we have the positive power as 2x plus 1. So rewriting that is the same like this, as you can see. 3 to the x minus 9 is equal to 0. So we have this. Now, we have this that you can see here. Since this one is 3 to the power x, we need to make sure one of these is also in the same alignment with 3 to the x. So to force one of the side to have 3 to the x as well, we are going to say or rewrite this as 3 to the x. But the 2 that you can see here is going to go out, as you can see here. It's the same because 2 times x will still give us this 2x that you can see. So 3 to the x times 2 is still 3 to the 2 times x, which you can see 2x. We still multiply by our 3 that you can see here to the power 1 is still the same as 3. Then minus 26, 3 to the x minus 9 is equal to 0. Now, this one is now the same like this. 3 to the x, 3 to the x are the same. We can now say that let 3 to the x be equal to y. So that anywhere we see y or 3 to the x, we replace it by y. So we can say that y square, you can see this is y, so y square times 3 to give us 3y square. So we have 3y square, as you can see, minus 26y, because this is y, minus 26y minus 9 is equal to 0. So we have this now. We can now use a factor method or to factorize. This 3y square is the same like 3y times y will still give us 3y square. To have this 26 here, we can say minus 1 times 9 or 1 times minus 9, which is still the same like this 9 minus 9. So 9 times 3 plus, if we can cross and add everything and we have minus 26y, then it means the factor is correct. Let's try to add all of these and see. Because y, 3y times y will give us 3y square. Then minus 1 times 9 will give us minus 9. Let's add all of these. If you can have minus 26y, then this factor is correct. Let's try and add all of these. So we are going to cross multiply like this. Minus 9 times 3y, we are going to have minus 27y plus y times 1, that is plus y. So if we add this, minus 27y plus y, we are going to have minus 26y. This will imply minus 26y. Since we have this minus 26y, then this factor is correct. Then the factor 3y plus 1, 3y plus 1, y minus 9 as equal to 0 are factors. So all of these are factors. So let's look for y now. So y minus 9 is equal to 0. So if y minus 9 is equal to 0, this implies that y is equal to, if we bring minus 9 to the right hand side, we have y equal to 9. Let's try the another one. 3y minus 1 equal to 0. 3y plus 1 is equal to 0. This implies that 3y is equal to, if we take this and go, it becomes minus 1. So divide both sides by 3 to remove here. So we have y equal to minus 1/3. So y is equal to 1/3 minus 1/3. So, but we know that y here is the fact that we can use let. Since we already have 3 to the x equal to y, we must replace y as 9, for we have one of the value as 9. So 3 to the power x is equal to 9. We are still going to replace that. 3 to the x, which is equal to, we already have it as 9. Now we must use a particular number where it must have 3 as base, so that when the base are the same, then the power will also be the same. And only that value or number is going to be 3 square to give us the 9. So this will be the same as 3 to the x will be the same like 3 square, because 3 square will be 9. And since the base are the same, then power must also be the same. So x in this case is equal to 2. In other words, x is equal to 2. If x is equal to 2, but we know that the other value where y was equal to 1/3, we can still say 3 to the power x is equal to 1/3 minus 1/3. So 3 to the power x, let's try that. 3 to the power x is equal to also minus 1/3. So we know that if it is 1/3 or minus 1/3, we must bring this 3 up here. But we know that these 3 have an invincible 1 as a power. If the power is 1, then if we bring it up, the power becomes 3 to the minus 1. 3 to the minus 1. And now if we are inverting, this minus 1/3 also become positive. So to make sure that we replace this as a whole number to cancel the fraction, then this is going to be the same as, instead of minus, now it's going to be plus. So we change the sign. The sign become plus. Then because this one is coming up 3, the power, instead of minus, the power that was 1 here will change to minus 1. So it is the same like 3 to the x is equal to, now it is plus, so it is just 3. The power now as minus 1. So since the base are the same, power also must be the same. So x is equal to minus 1. Another value, x is equal to minus 1. So the two values of x is x equal to minus 1. And in the case where here x is equal to 2. Those are the values of x, as you can see in this expression, where they're asking us to find the value of x. As you can see, where we have to substitute y in some area and try to make it in the simple form to factorize. Then we now have the total final values of x, which you can see as 2 and minus 1. If you want to see more of this, which we share, then you want to make sure to go ahead to subscribe and enable the notification bell icon, so that anytime we put a new video, you'll be the very first to get notified to see what we have as new for you. See you in the next upload, and bye-bye for now.